right, so let's say we ran our Michael reaction and we started out with this compound here, this diketone, and we started out with our alpha beta unsaturated compound, alpha beta unsaturated ketone as this compound. You will go back and watch the previous video. Next thing we can get is Robinson annulation. The first question is, why does it occur? Well, in order to make your Michael reagent, you used hydroxide. You use a strong base, and the Michael reagent is a strong base. So once you've finished reacting your alpha beta unsaturated ketone or whatever your reagent is you're reacting with the Michael reagent, you still have base present in the reaction, and so that base can deprotonate an alpha carbon. In this case, we have two alpha carbons we can work with, here or here. And what these alpha carbons are going to do is they're going to deprotonate, and we're going to get carbanion attack on the carbonyls. Now, we're going to try to stick to problems where these are symmetric. We'll talk about this in a minute. You can definitely conceive of far more complicated problems. It is an exercise in tedium. It doesn't necessarily teach you the basic concept. So let's say this carbon attacks here. Let's number the carbons. 1, 2, 3, 4. So we will form a four-membered ring. 1, 2, 3, 4. And if you look at what's attached to carbon 1, we've got the methyl group, and we've got our starting carbonyl hanging off. If we look at carbon 3's got this ketone hanging off. And if we look at carbon 4, it's got the methyl group and the alcohol. Now, what if this attacked instead? So let's say I switch to this product. We have 1, 2, 3, 4, 5, 6. So now, for the reaction blue, draw the six-membered ring. And we'll number the carbons. 1, 2, 3, 4, 5, 6. Carbon 1 doesn't have anything on it. Carbon 2 has the ketone. Carbon 3 has a methyl group. Carbon 4, nothing on it. Carbon 5 here is going to have that branch hanging off. Carbon 6, we're going to break open, and we're going to get our alcohol. So there's two products here. There's the four-membered and the six-membered ring, and the question is, okay, both of these are potential candidates for the Robinson annulation. Which one occurs? And if we're being fully honest here, this doesn't occur. You can make cyclobutane, it's just not particularly stable. Cyclohexane is always the more desired product. Now, you may isolate trace amounts of this, but generally speaking, the only thing you're going to create here are cyclohexane rings. Now, you would not be wrong to write this as a product. Probably just get formed in some trivial amounts. But the correct answer, if we're saying which one are we actually going to make, which one do we expect to extract out, it's going to be this answer down here. Now, what can happen next is we can get a condensation reaction. Because if you look at aldol condensation reactions, that's effectively all you've done is an intermolecular, within the molecule, intermolecular aldol condensation. And if we can, meaning that we have hydrogens here to abstract, we can definitely do a dehydration reaction on this and end up forming another alpha beta unsaturated ketone. Now, in this case, for this one up here, the alcohol doesn't really have any, I guess there's a hydrogen there. We don't really have any hydrogens on this adjacent carbonyl, so we're probably not going to get a condensation. Now, next interesting question for particularly precocious students. What's stopping this carbon from reacting up here? And if we count the carbons, it's 1, 2, 3, 4, 5, 6 carbons. There's really nothing stopping that reaction as well. We can definitely get subsequent internal Robinson annulations going on. Why don't we report those? This ends up being a three-membered ring if you really build it up. Gets super complicated. On top of that, once you start throwing these double bonds in here, you start putting a lot of restrictions on the string strain. So I would say in general, the reason why we probably don't focus on extra internal aldol condensation reactions beyond the initial Robinson annulation is 1, super complicated, hard to explain, and 2, we start creating these rings that are really folded in on themselves, and we start getting a lot of steric strain. So that's Robinson annulation. Again, you can actually generate two products, not one, but that said, the cyclobutane ring is probably not the likely candidate here because it's too sterically hindered. Most likely you're just going to kind of generate this six-membered ring. With the six-member ring, if you can, you're going to end up going a condensation reaction to give you an internal aldol condensate product. And that's as far as you're going to get. We're not going to worry about subsequent reactions. Probably not going to happen because of the steric hindrance.